the marketing spiel for VUCA. Let's talk today about our presenter. We're privileged to have Ken Titmus with us. Ken runs his own business called Kent Outsourcing Services, trading as Demand Driven Africa. He consults to well over 200 companies, providing their employees with education courses and consulting in manufacturing operations and particularly supply chain management, which is what he's talking about today. The professional body for supply chain management in South Africa is called SAPEX. Ken has been involved with SAPEX for over 36 years, from running the Cape Town chapter to being on the board of directors and twice holding the position of president. He's an endorsed instructor for APICS, CPIM, CSCP, and instructor development programs. Now that's the last of the initials from me. He's an endorsed instructor for the Demand Driven Institute courses, which have lots of D's in them, as well as a certified trainer for the Fresh Connection business simulation software from InChange. Kent Outsourcing Services is an affiliate of the Demand Driven Institute, as well as channel partner of Demand Driven Technologies and their IntuiFlow software. Over the last 35 years, Ken has presented many papers and workshops at South African and overseas supply chain conferences. He's currently spending most of his time promoting and presenting the Demand Driven Institute courses, as well as implementing the DDMRP methodology at his clients. So today he's giving us an introduction to demand-driven materials planning. Over to you, Ken.
Jenny, thanks a lot. Yeah, I didn't know I was as good as you mentioned there. But what I want to talk to you about is nothing about coatings or raw materials that you use in your businesses. I want to talk about something I think is just as important, and that is supply chain management. Because you can have the best product in the world, but if you don't have a lot of friends in the supply chain, getting you your raw materials and getting those finished products out to your customers, it's not going to work, is it? So supply chain management has come to the fore, I think, over the last few years, particularly since COVID, when we realized that the supply chains were breaking up rapidly and we were getting problems getting our products, etc. So supply chain management has come to the fore over the last few years. So I think that's very important, and it's helping, and the demand-driven methodology I'm going to talk about is helping us to survive and thrive in this VUCA world that we're living in, which is volatile, uncertain, complex, and ambiguous world we're living in. I've been involved, as Jenny said, for a very long time in the planning area of businesses. And we've moved from what was developed as materials requirements planning into a demand-driven materials requirements planning, which is proving to be very successful with our clients. So I think Jenny mentioned most of what I've got on this slide here. Yeah, I've got lots of supply chain certifications, and I think that's important. There's a lot of information out there. There's a lot of certifications from different organizations like Apex and ISCA, etc., and the Demand Driven Institute. And I present many of these courses, or have done over the years. So yes, I am an affiliate of the Demand Driven Institute, and we are also a channel partner of Demand Driven Technologies that provides the software which we use to run the demand driven methodology. But supply chain management is not new. I think if you go back to the Bible, you'll probably find Joseph was one of the first supply chain managers. And Pharaoh had a dream, and Joseph took that dream as a forecast into the future. The dream was that they were going to have 7 good years and 7 bad years. And so Joseph stored 20% of the grain in the good times so they could distribute that in the bad times. And I think he became, from becoming, when he started off as a prisoner, he became second in command in the country at that time. So you can see supply chain management was even important in those days. But supply chain networks as well. I mean, they go back for thousands of years. with the spice route and the silk route from the Far East to Europe through very complex dynamic network of land and sea routes going through many countries, many traders, many merchants and middlemen. But then things happened, changed in the the 15th century when the Portuguese opened up the sea route around the Cape here. So Bartholomew Dias in the 1480s actually opened up the route, and then Vasco da Gama in the 1490s, actually expanded that. So they could get their products directly from the Far East into Europe without having to go through all these middlemen. But nothing's changed, has it? Today, we still get our products from the Far East by Temu or one of these other companies. It gets delivered by DHL to our doorstep. So, things are improving all the time. So nothing's changed. If we go back to the way we planned materials in our supply chain, and it's very important to understand that materials are key in your business, and the flow of materials in your business is absolutely key. And we need to keep those materials of raw materials flowing into your businesses and the finished products flowing out of your businesses, because any time that material stands still in your supply chain, it's gathering dust and it gathers cost. So we need to try and get materials moving as rapidly as possible through the supply chains. So back in the day, back in the 1960s, well, actually in the 1970s, Joseph Orlicky wrote this book, Materials Requirements Planning. It's been our Bible, I guess, in materials planning since the 1970s. About 1975, he wrote it. And the materials requirements planning, it gave us much better. Prior to that, we were using reorder points and things. Prior to that, so it gave us time phase planning, level by level, bill of materials explosions, dependent demand planning. We got benefits from it: component synchronization, reduced inventories, and improved priorities. And if you go and have a look at a copy of his book, he reckoned in 1975 there was about 700 companies that were implementing this methodology, and mainly in America. And it became the way of life. But it was conceived in the 1950s. We knew in the 1950s, if we had a bill of materials for a bicycle, I could say I want to build 100 bicycles, and on a piece of paper, I could calculate how many bits and pieces I needed, and nuts and bolts and washers and chains and saddles and all the rest of it. The problem was, if you've got one finished product and 6 raw materials, you can do it on a piece of paper. But if you've got hundreds of finished products and thousands of raw materials, you don't have time to do all the calculations on a piece of paper. And we didn't have computers in those days. But in the 1960s, around about 1965, there was a chap working at IBM, and he developed the MRP, Materials Requirements Planning algorithm, for his IBM clients. And then the whole thing was commercialized in the 1970s when Joseph Orlicky wrote his book. And I think by 1990, most manufacturers probably had put in some form of MRP system. I put my first system in the late 1980s at a company here in Cape Town called Plastamid in those days, and we put in an MRP2 system, and it was reasonably successful. And I think one of the reasons it was reasonably successful is because we weren't in a VUCA world in those days. We were still in the bad old days of apartheid. Nobody wanted to do business with us. We didn't want to do business with them. We got waste fibers from Sands Fibers here in Cape Town, and we converted it into engineering polymers. And we had a few local customers. And so we had a very small supply chain. MRP was working great. After that, I left that company and started teaching people about MRP and helping companies to implement. But now, if we go and have a look at some data from America here, this is the return on assets for the US economy going from 1965 when MRP was developed. And you can see the blue line here went from about 4% to currently around about 2015 here, went down to nearly under 1%. And here you can see the implementations of different materials planning systems we've put in place over this particular point in time. So we had MRP in 65. MRP2 which added some other functionality to the systems in about the 1980s. Then we had ERP in the 90s and advanced planning systems in the 90s as well. But nothing seems to have helped the return on investment in the manufacturing sector. So whatever we've been doing hasn't really been working. And one of the things is that we're living in this VUCA world. As I mentioned, it's very volatile, very uncertain, very complex, and very ambiguous as well. And probably this one gentleman here over the last year has caused more VUCA in the world, pretty well to everybody with his tariffs. And, it's becoming a big problem. It's never going to go away. So our supply chains are volatile. It's not about when something is going to, or it's not about if something is going to happen. It's going to be when is it going to happen. We're living in an uncertain world, and we tend to drive our planning systems on a forecast because we haven't had any other way of doing that up until now. However, we know that a forecast has three truths about it. It's always going to be wrong. If you get it right, it's a bit like you winning the lottery. And I guess not many of you have done that, seeing as you're sitting there listening to me. So it's always going to be wrong. And the longer we forecast out, the more inaccurate it's going to be. And the more detailed we try and get into our forecasts, getting right down to those SKU level, the more error rates we're going to get into it. So over the last decades, we've been trying to improve our forecast accuracy. It's not going to happen, okay? So we need to find another way of planning our businesses. We live in a very complex adaptive system, which is actually great because our planning systems that we developed, the MRP planning system we developed, are very linear, okay? They assume a supply chain, and supply chains are not chains, they're networks. We live in this complex network. And thank goodness we do, because if we lose a customer over here, we can pick up another one over there, or there's a supplier goes down over there, we can find another one over here. So thank goodness we do live in this complex adaptive system, but it does make it more difficult for planning. And of course, it's very ambiguous as well. It's a bit like driving down the road and your windscreen wipers are not working and it's pouring with rain. You can see something out there, but you're not quite sure what it is. So we're drowning in data, okay? But we're starved of relevant information. Now, when MRP, Materials Requirements Planning, was developed in 1965, this is what the world looked like. And I can probably attest to this because I know I don't look that old, but I actually started working in 1965 as an engineering apprentice for a company in the United Kingdom. And supply chains had very low complexity. Product life cycles were very long. Customer tolerance times were long. Product complexity was low. Customization was low. Variety was low. I think in the 60s, Colgate and Crest had one toothpaste each. I think Crest today has something like 42 toothpastes. I mean, come on, guys, do we really need 42 different types of toothpaste? You want to try forecasting one toothpaste is hard enough. Try forecasting 42 different types. Longer lead time parts we have today. Our accuracy in forecast has gone down. As Jenny said, I've probably worked with over 200 companies over my career as a consultant and educator. And not once have I gone into a company and the boss has said to me, you know what, Ken, we have too little inventory. How do I get more? It's always the other way around. We're drowning in inventory. I've got too much of the wrong stuff, not enough of the right stuff, and just too much stuff. How do I sort this out? And then, of course, we've got transactional friction, which years ago was very high because we did everything by post. The orders came in by post, maybe the product went out by post or whatever, invoices went out by post. And of course, the old famous saying was, your check is in the post. Today, in fact, I got an invoice from a colleague of mine who's done some work for me. He sent me the invoice. I paid him within 5 minutes. Okay, and I have the ability to do that with the technology we have today. I just wish our companies could pay their bills in 5 minutes and not 30 and 60 and 90 days. I'm always having to phone for my money. It really annoys me. I love having financial people on these courses. and talk to them about this. And why do we have to wait 30 days? It's because of the old transactional friction that goes back to the 1960s. So, what about inventory implications in our VUCA world? Well, supply chains have elongated, they're fragmented, while customer tolerance times have dropped dramatically. The disparity means holding stock at some strategic point is a must if we want to grow sales. And this means that planning horizons are more remote from the actual demand realization. So we have these long range forecasts, which were even more inaccurate. Also, there's more products with shorter lifespans to manage. Many use common components and resources in your plant. And this means managing stock positions effectively is a must for effective capital and resource management. It also means that detailed item level forecasting is becoming much harder. And as I mentioned, we know the 3 rules of forecasting is they're going to be wrong. The longer they are, the more wrong they are. And the more detailed they are, the more wrong they're going to be. So how is this conventional approach faring for us? Let's just take one item, one stock keeping unit. And if we look at that stock keeping unit and we say there's 2 universal points in the life of this item here, where we have 0 here, okay, is point A. I've got nothing, all right? And maybe I've got back orders which I need to fill. Over on the right-hand side here, I've got a point where I'm getting to the point where I've just got a little bit too much of what I really need for my current requirements. Now, if I draw a dotted line between these 2 points here, this represents the return on your inventory investment. And remember, inventory is an investment. You're investing in that inventory. And you want to be able to get a return on that investment. If you've got nothing and back orders, you're not getting any return. It's costing you money because you're probably going to have to fly parts in. If you go over this point B here, where you've got too much, you've invested money in something you can't sell, you can't use. It's gathering dust and cost in the warehouse, and you're not getting any return on it. So ideally, we want all the items in our warehouse to be sitting in this optimal range here. Okay, if they go a little bit to the left or the right, it's still okay. We're still getting a return, but we certainly don't want to get it over to the far right and the far left here. Now, we've done this many times, and we go into a warehouse and we look at the number of SKUs that you have in the warehouse. And we find that there's a huge number of items in the warehouse where we don't have enough or we're out of stock, okay? And then there's another pile of items where we have too much. Generally, this hump on the right is a little bit bigger because buyers and planners, buy double to stay out of trouble. They don't want to run out of inventory. And we have very few items that are actually sitting in this optimal range here. So we don't have enough of the right stuff. We've got too much of the wrong stuff. We just have too much stuff, and we don't have enough of it sitting in our optimal range here. And this is very typical of what we find when we go and do an analysis of a company's warehouse. And then worse still, every time we run MRP, it flops from being, oh, I'm okay, to being, no, I'm not okay. Let me get some more. Oh, I'm okay again. And then I'm not okay. And it flops backwards and forwards between these 2 points. And many companies report this. So the 3 bottom line effects are we just have chronic shortages, we have excessive inventories, and we have high expedite expenses because we're now flying stuff in, we're having to expedite stuff in, or if we've got a distribution supply chain where we're cross-shipping between warehouses, and all this is a waste. And the boss is saying, I don't understand it. You're telling me you can't ship the order, but we got so much inventory. Yeah, sorry, boss, but we got not enough of the right stuff. We got too much of the wrong stuff, and then just too much stuff. So maybe the real problem is somewhere else in the supply chain. And we think probably the bullwhip effect. I don't know whether you've heard of the bullwhip effect. By the way, Apex, or ASCM as they're called today, one of the best things they've ever done over the years is to create a dictionary. And if you haven't got a copy of the Apex dictionary, don't worry. You can go onto your cell phone, go to ASCM dictionary, and you can get a free dictionary of all the terms that we use in supply chain management. So it's a very useful resource for supply chain management. So we've known about this bullwhip effect for years. And if you've ever played the MIT beer game, it illustrates how this bullwhip effect actually happens in our supply chain. So I've got a supply chain here. I've got a foundry. They make castings. I've got an engineering company here that machines the castings. I've got a subassembler here. Maybe it's a gearbox casting they've made, and it goes down to the subassembler. They make up the gearbox. The gearbox then goes down to the car assembly plant, goes in your motor car. So what happens is if there's a small change in the demand for the end item, the motor car in this case, when we send the signals up the supply chain to the foundry, they get distorted. We get this transference and amplification of variability going up the supply chain. So we get this demand signal distortion going up the supply chain. But we also get supply continuity variability coming down as well. Because if the foundry has a glitch and can't deliver the castings to the engineering company today, this could have a huge effect down here, ultimately at the car assembly plant. So now the more parts we have in our supply chain, the worse this effect happens. So maybe the true solution must deal with demand and supply distortion together. We've got to stop this demand and supply distortion going up and down our supply chains. Now, the basic MRP equation, which was written by Dick Ling, was the guy's name at IBM in 1965, has not changed one iota. So if you have an ERP system with an MRP module in it, the algorithm there is exactly the same as Dick wrote back in 1965. It has not changed. MRP was never designed to manage stock. It was designed to be the most perfect order calculator and always nets your inventory to zero. So that's how I used to sell it when I went into a company. Hey, boss, tell me what you want to make. I'll tell you exactly what you need, when you need to order it, when you need to make it, and we'll drive your inventory to zero. And it doesn't get any better than that until something goes wrong. And guaranteed, something always goes wrong. So MRP only produces a realistic schedule when we have these three assumptions in place. Number one, the demand is known and does not change. Well, we don't know what the demand is. We're using a forecast. We know it's wrong and it's going to change. There's sufficient time to accomplish all the required activities in the customer tolerance time. Now, our customers are not very tolerant today. They want this stuff now, okay? So the demand time fence in your MRP system is supposed to be set to the customer tolerance time. But because these have got so short now, we actually generally set it up as the cumulative lead time. And that's another reason why MRP is not working. There's no variability in execution. Well, we know that things are going to go wrong in execution. Nothing ever goes right. Murphy strikes. And Carol Patak and Chad Smith, who are the partners in the Demand Driven Institute, and they put this whole methodology together, wrote this book explaining to people why their current planning systems are not working for them, called Precisely Wrong. So we don't want to be rough. We don't want to be precisely wrong. MRP is making you precise, very precise, wrong. We want to be roughly right. Okay. So I first came across this methodology in 2012. It was in 2011 that Carol and Chad wrote this. They wrote the third edition of Orlicky's Materials Requirements Planning. Remember the one that Joseph Orlicky wrote back in 75? Plossall updated it in about 95, and then they added the DDMRP stuff in about 2011. I went to an APEX conference in America, and I saw Carol Patak was on the speaking committee, or she was presenting a paper. Now, I know Carol from way back at the turn of the century, around 2000. I was president of SAPEX. She was president of APEX. And the presidents of APEX always love coming out to the SAPEX conference because it's so much better than theirs. And I can attest to that. I've been to about a dozen or 10 of theirs at least. And so anyway, I met Carol in the year 2000, and she was working at IBM in those days. So I went to this conference and I saw, oh, Carol's on the speaking list here. Let me go and see what she's talking about. Well, it was at that point that I was really getting upset with my clients because they couldn't seem to manage to implement their MLP systems and get the results that we were looking for. And I didn't understand why until I went to listen to Carol. It was the first time they articulated the demand-driven methodology to the Apex community in America. I tell you, I walked out of that presentation and I went to my colleagues that were with me from South Africa here and I said, guys, there's no ways I'm retiring because I've been telling them I was going to retire. I was fed up. I said, I've just listened to Carol. What she's intimating here, it will work. And I'm hitching my wagon to Carol. So that was the first time that the bigger planning community got to know about demand-driven materials requirements planning. So what is it? It's a method to model, plan, and manage supply chains to protect and promote the flow. Okay, flow is very important. We want materials to flow. We don't want them to hang up in warehouses gathering dust and cost. So promoting the flow of relevant information and materials. DDMRP uses strategic decoupling points to drive supply order generation and management through the supply chain. Now, we've had some great people over the years. We've had OCCA, and with his materials requirements planning and distribution requirements planning. We've got Ono, Toyota Production System, just in time, and more recently, Womack and Jones that termed the term lean. Great stuff. Theory of Constraints and Ellie Goldratt, Edward Deming and Six Sigma, all great tools. And we need to know how they work because we're not throwing, as we say in English, the baby out with the bathwater. We're taking the best of these methodologies, which don't work on their own. We're putting them together with some innovation and coming up with demand-driven MLP. So what are we going to do is we're going to position inventory in our supply chains. We're going to protect that position so it never ever runs out of inventory. And we're going to pull from those positions. But not only that, we're going to adapt those positions because we know that the situation today is not going to be the same as next week or next month because our markets changes. It could be going up, could be going down. We need to adjust those positions accordingly. So there are 5 components of DDMRP, and the first one is positioning, deciding strategically where you're going to keep inventory in your supply chain. Once we've decided that, we're going to then set up a buffer of inventory. And I like this little icon here of the shock absorber because what it's doing is it's acting as a shock absorber in your supply chain because of demand and supply variability. The same way your shock absorber on your car takes out those lumps and bumps and potholes when we're driving down the road. But we know, as I said, the demand out there is going to change on a regular basis. So we need to dynamically adjust those buffers. They need to get bigger if the demand's going up. They need to get smaller if the demand's coming down. So we automatically set up this dynamic adjustment. So this sets up your operating model. And once we have the operating model running, we can then we can do the demand-driven planning, determine when we need to replenish the stock in those buffers. And something we didn't have with traditional MLP, but do have with demand-driven MLP is visible and collaborative execution, which is another big bonus. Let's go back to our supply chain here that we were looking at. Now, if I decide that I'm going to put a buffer, and this little icon here is what we use as a buffer. If I decide I'll put a buffer in the supply chain at this point, so in this buffer, we're going to keep machined components, all right? So what happens is as the demand signal goes up the supply chain, it distorts, but as soon as it hits the buffer, it stops dead, okay? But it starts up again until it hits the next buffer. We get the same coming down the supply chain. So if the foundry has a glitch, not so much a problem because there's some machine castings sitting in this buffer here, which we can use to make the gearboxes and get them off to the car assembly plant until we can catch up again. So this stops the transference and amplification of variability in both directions where it matters worst. But also planning horizons are shortened. So we only need to plan between buffers. So we've now shortened the planning horizons, which make it a lot easier to manage. So in our buffer, we have three zones. The top zone, the green zone, is basically the order size, our order quantity, minimum order quantity, and it determines how often we're going to be replenishing the stock in this buffer. The yellow zone in the middle is basically the prime coverage, which is generally the average daily usage of this part times the lead time to replenish the part. And then the red zone is calculated as the safety. Now, this is not safety stock. It does not work in the same way as safety stock. This is the absorption in your shock absorber, okay? The safety is in there. So if you've got a lot of variability in your supply chain, you probably have a big red zone. If you've got less variability in your supply chain, you'll have a smaller red zone. But we calculate all these things. So we set the buffers up with different groups, different item types, different lead time categories, different variability categories, and then we need to understand the individual parts, lead time, minimum order quantities, location if it's a distributed part, and its average daily usage. And then the computer system will work out the zones for us and in the buffer. Okay, and I'm not going to go through how we do this. It's reasonably simple to understand, but of course you don't have to do it manually. The systems will do all this for you automatically. So critical difference now is that MRP was not designed to manage stock positions. It was designed to be the perfect make to order calculator. MRP drives your inventory to zero. DDMRP never nets to zero. The objective should always be to have some inventory in your buffer. It should never run out. And of course, safety stock is there really as kind of a fire extinguisher, where the safety in our buffers is more like a firewall. You know, we have firewalls in our computer systems that stop nasty stuff coming in and going out or getting through that wall. And that's really what your buffer is doing. It's stopping that variability going up and down the supply chain. So, as I said, we need to adjust the buffers as well. If you look at this little diagram here, the black line here is the average daily usage, okay? And this is over a period of time. So you can see over a period of time, we started off with an average daily usage of, I don't know, 20 or whatever it is here. And it's increased as we've gone forward. The buffer has got bigger. There was a period here where it got a little bit lower, so the buffer went down and then it went up again, and we're in a period where the buffer's going down again. So the demand's going down. So this happens automatically in your system. You don't have to do anything. It automatically adjusts the buffer according to the market conditions out there. However, there are times when we know things that are going to happen. For example, seasonality. We're coming into a lot of companies' season now where they're going to sell a lot more than they normally do. And I can go in and put in manual adjustment factors to take that into account. So there are many ways in which we can adjust these buffers. I'm not going to go into detail here, but it's possible to adjust the buffers or the individual zones if you need to. So most conventional safety stock and reorder point systems, they're static. They're not dynamic. People set it up, they set it and forget it. But they should be adjusted. And on a DDMRP system, these adjustments take place daily, okay? So it very gradually gets bigger your buffer and gradually gets smaller, but those adjustments are made automatically daily. So what about the demand-driven planning part of this? So we're now starting off with a more relevant demand signal. Conventional MRP and MRP planning systems, we use the forecast, which we know is not right. However, with DDMRP, we use sales orders. We use actual demand to determine when we need to replenish the buffer. So sales orders and actual demand are highly accurate, whereas planned orders and forecasts, highly inaccurate. So we're going to continue with a more relevant demand signal. And we're using a unique formula here, which we've never seen before, and it's called the net flow calculation. But if you look at what every planner cares about today, what's coming to me? What am I ordered, either out of my factory or from my supplier? What's coming into me? What are people committed to deliver? What do I have in the warehouse today? What's my current inventory balance? What demand do I need to fill immediately? In other words, what do I have to ship today and in the past? And is there any future demand that might be relevant that I want to include in my net flow calculation? So the net flow calculation is very simple. We use it to determine when we're going to replenish the stock in the buffer. So it's on hand. What have I got in the warehouse? What's coming into me? How many have I ordered? Minus the qualified sales order demand. Now, the qualified sales order demand is what have I got to ship today? And if I've got any in the past, and is there any relevant future demand I want to include in my calculation? That will give me the net flow. Now, if my net flow position is in the yellow zone or in the red zone, which it happens occasionally, I simply get a request from the computer system to replenish the stock up to the top of the green zone. It's as simple as that. I mean, really, it doesn't get any more difficult than that. So every day, for every item in your system, the computer will calculate your net flow position. If it's dropped down into the yellow zone or the red zone, you will get an order replenishment signal up to the top of green. And you just action it. It's as simple as that. But we also have execution, okay? And execution is about, we're changing the way we look at priority here, because with the current systems, priority is always about due date. You know, we've given a supplier an order with a due date, and as soon as we've given him that order, things can change in our system, and that due date's not relevant anymore, okay? But in DDMRP, priority is set by buffer status, okay? So we look at the buffer status for all our items and determine what we should action first and what we should action second. For example, here's a company, it's making manufacturing orders here. I've got some make to stock orders, so we're filling up buffers. And I've got a make to order one here for Supertech. Some are needed on the 12th, then on the 14th, then on the 16th. I've got two. Well, I'm probably going to make Supertech first because I can invoice that and get some money for it. These other two, this first order and the third order, both due on the 12th of May. Which one do I do first? Well, I don't know. And then probably I'll do the 14th one and the 16th one. But if I now look at my buffer status, yes, I'm going to do the Supertech one first because I'm going to invoice that, get some money. But the buffer, my stock buffer that's in the worst situation is this one, and it was only due on the 14th. So I'm going to do that one first, and then I'm going to do this one second, then I'll do this one third, then I'll do that one fourth. So what a lot of companies do is they just put a flat screen TV up in their factory and project that on it. The factory knows exactly what to make and in what order to make it, okay? So you don't have to tell them anything. Make this one first, then do this one second, then this one third, that one fourth, and that one fifth. It's as simple as that. We work on buffer status priority. So we want to say goodbye to that bimodal distribution that we've got in our current warehouses and move to a more normal distribution, okay, where the majority of our items are sitting in that optimal range. But that doesn't mean everything's sitting there. You're going to have parts out with, going to ask yourself, why don't I have any stock of this part? Why have I got too much of this part? And that's what we do on a daily basis. We want our planners and buyers and people to spend their time working out how we can sort out these items that are sitting around the A and B here, not worrying about what they're going to be ordering and how many they should be ordering. Let the system do that, okay? Let's use our brains to try and get those items that are sitting out on the tails here further in to the optimal range here. So we're spending our time daily improving the system, okay? And that's what we should be doing. Also, if you look at the conventional planning system as we had it in the past, we had a sales and operations planning process, which is strategy. We had a master production schedule, which was tactics. And then we had materials requirements planning, which was operational. And on a monthly basis, we would have a sales and operations planning meeting. We'd pass the information down on the master schedule, and the master schedule would create a schedule and drive materials requirements planning. And something goes wrong, we go back next month and start again. So we destroy everything we had here and start again. And that's how we used to work. So if you look at it, effective SNOP has always been about projecting ranges. So we might say here, look, we might sell 80, but if things go well, we might sell 120. Let's take a single number in the middle, okay? So convention, however, forced us to use a single number to send down to the master scheduler. Master scheduler, make 100, okay? However, that single wrong number was propagated down through materials requirements planning. So the master schedule said, okay, we'll make 100. MLP said, oh, okay, you want 100? Oh, this is what you need to go and buy. How many? This is what you need to go and make, how many and when. And then when we get the actual order in, the customer wants 110. Oh, sure, but we haven't got enough to make 110. Everything changes, all right? So this was the big problem that we had. However, with DDMRP, there's our forecast. There's our forecast range. We have that range. Well, yeah, conservatively, we might only sell this much. Optimistically, we might sell that much. Let's take that middle number, which what we did, and put it in a master schedule. We now take that projected, we call it the average daily usage, and we put it into master settings and create a buffer. There's our buffer. And as we go through the months here, this could be like over a 12-month period, the demand for our product goes up. Okay, there's our average daily usage going up. The buffer's getting bigger. Okay, until we come to the end of the year and we have a capability range now. Okay, maximum inventory that will be sitting in this buffer if everything goes wrong is going to be the top of green. In the worst case scenario, I'll get more orders than I thought I was going to get. Then I've got all the way down to this maximum upside limit here. So I have a capability range, which I can now reconcile with my forecast range. Okay. I just love this chart here because it just explains how DDMRP just works so much better than the traditional way that we've been doing things. So what we've developed is what we call the demand-driven adaptive enterprise model. All right. And can you still see me, Jenny? Because my other computer's gone off.
Yes, we can still see and hear you. Go for it.
Okay. No, it's just that my second computer went off and I thought, oh, that's a bad sign. All right. Okay. So we still have a strategy, which is what we call the adaptive SNOP process. We still have our tactics, which we call the demand-driven SNOP. And we have our operations, which is the demand-driven operating model here. So, and we still have business plans and parameters coming from strategy down to tactics, okay? And the tactics, instead of creating a master schedule, we have model configurations and master settings that go down to the operating model. We get continuously on a daily basis variance analysis. So we are creating a model down here, an operating model, and we're seeing how the model is working. And on a daily basis, we're adjusting the model. If it's not doing what we want it to do, then we adjust the model on a daily basis. And I just love this icon in the middle here because it's gold on the one side and blue on the other. So half of the objective of this demand-driven SNOP is to make sure that we're making as much money or gold in our operating model down here. But now what we do is we take our forecast and demand management and we feed it into the demand-driven SNOP process here. We take our operating model and we project it into the future, and it allows us now to send back to strategy model projections, innovations, and strategic recommendations. So now we have a process in our business that is bi-directional. Whereas before it was sales and operations planning, master scheduling, MOP. Oh, it's all gone wrong. Destroy it, start again. We've now got bi-directional information going down our strategy, down to tactics, to operations, back from operations to tactics, and then back to strategy again. Something we've never, ever had before. So this is absolutely brilliant. And of course, our operating model is being driven by actual demand. And of course, our strategy, like it always has been done, it's being driven by market-driven innovation, which is the way it's always been. So this is the model we want companies to be putting into place, so to help them adapt in our VUCA world here. So what are the benefits of this? This chart was put together by an organization called Camelot. They went and had a look at lots of DDMRP implementations and what they had achieved. And we've got life sciences and chemicals and consumer packaging goods, industrial manufacturing. Yeah, I guess you would probably fall in the chemicals one here. To me, it's all about improving customer service. Okay, in chemicals here, we got a 7%, probably not as many as the other areas, but 7% increase in customer service. If we can increase customer service without increasing our inventory, then we're going to get more business. Best in class with 34% improvement. Inventory reduction here, quarter, 26% down. So we reduced our inventory down 26%, increased our service levels up 7%. Okay, best in class here was 52%. Normally, we talk about 30 to 40% reduction in inventory. And then in some cases, we can reduce lead times as well. And of course, reducing lead times always has an enormous effect in our supply chains. So if we look at the proven benefits, we're getting improved customer service. Constantly, people are talking about 97, even up to 100% on-time fill rate performance. At the same time, right-sizing their inventories, okay? And typically reducing inventories to 30 or 45%. This, by the way, pays for any implementation. Most implementations are self-funding, okay? Because if you can save 30 to 40% of your working capital, that's going to pay for an implementation. In manufacturing, in many cases, we've got lead time reductions. We've seen lead times up to 80% reductions in manufacturing. But another great one is lower total supply chain costs. We're taking out all those other costs that we didn't need, like expediting and cross-shipping across networks and what have you. But I think one of the great ones is, and you can't quantify this, that it's easy and intuitive. I can teach people in 2 days how to run this system. Previously, we had to do Apex courses that CPIM was certified in production and inventory management. And when I did it, there were 5 exams you had to go through to understand how to run the planning systems that we used in the past. Today, I can take you for over 2 days. You'll get it. You'll understand how to run the new planning system. It's very easy. It's very intuitive. And when we've done this and the guy had got the planners in the boardroom there and the training room, showed him how it works, he said, but this is too easy. What do we do after tea break in the morning? That's where we want you to use your brains to improve the system, okay? That's what you should be doing, using your brains on improving the system, not trying to work out what you should be ordering today or tomorrow. Let the system do that for you. Jenny spoke about SAPIX. We had the Demand-Driven World Conference in Cape Town, at the SAPIX conference this year in June. Carol Patak, was one of the partners, came and spoke to us. And she spoke about, well, surviving and thriving through supply chain chaos. And these were some of the benefits that she spoke about: higher service levels, strong defense here, right-sized inventory, competitive weapon in your supply chain. We've seen companies that have adopted this. In fact, one early adopter made the comment, make sure that your competition doesn't get hold of this before you do. Because we've seen whoever is in an area where you've got competition, the first company that goes for this has a huge benefit, and they almost leave their competitors in their dust. Okay. So don't let your competitor get into this before you do. So it is a competitive weapon out there, and it's going to improve your cash flow. It's going to improve your return on investment. And what is the boss looking for? He's looking for an improved return on investment. But he thinks, or she thinks, that the way to do that is to reduce cost. It's not. It's about improving flow in your business. If you can improve flow in your business, you will get a better return on investment. So we're going to give the boss what he wants, what she wants, return on investment, and yeah. So how do we do that? Well, I can come and talk to your company. We can do a 1.5 hour intro question session with your company. But one of the most powerful things is to do a simulation. Take your actual demand data for the last year in your warehouse or warehouses, we can do as many as you like, and see that bimodal distribution. And then we can run a simulation to say, well, if you'd have used demand driven, this would have been the situation. Your average inventory would have been here. Your service level would have been 99.7%. And we can do that for you. And then if you're really interested, attend the 2-day demand-driven planner course, and you'll get a lot of details. When you walk out of that course, you actually understand how to implement this system. And typically, people are getting good return on investment within the first 3 months of implementing. The software itself is add-on, so I don't care what ERP system you've got. We can add software, and it's cloud-based software, and it can add into the current software that you've got. And we've got many links into different softwares like SAP and Cispro and Microsoft Dynamics, etc. If you want to know more, go to the Demand Driven Institute website here. Okay, demanddriveninstitute.com. Hundreds of case studies, videos, downloads. You've got all the information about those DD certification programs that you can get there. But if you've got any questions, I can answer those for you now. What are we? Oh, we're almost 4 o'clock. If you want to get hold of me, there's my contact details, and I'm very happy to speak to you and give you a bit more information. So, Jenny, have we got
Yes,
any
thank you very
questions?
much, Ken. That was very interesting and applies to all of us, small companies and big companies.
Absolutely.
Is it a system that's affordable to a small company that, for example, might have all their stock planning on Excel and their production planning?
Probably if you've got an Excel, no, I would say no. You need a company that's really got an ERP system, because we're going to extract data out of your ERP system on a daily basis, like on-hand balances, customer orders, manufacturing orders, etc. We do that net flow calculation in the software and then send back the requirements to your ERP system. And then the buyer would create the purchase orders, and the manufacturing orders would be done by the planner in the factory. So
Okay,
ideally, we need an enterprise resource planning system. So if anybody's got things like SAP or Microsoft Dynamics 365, or they've got Cispro, or there's a number of different ERP systems out there, because we take the data from your system, do the analysis and the calculation, and then send it back. This is what you should be doing.
Okay. If anyone else has a question for Ken, please quickly type it in the Q&A, because we don't have too much time for questions today. Okay, I've got another one that I
Yeah.
think lots of people might be wondering, and that is, how much artificial intelligence have you included in your software?
Everybody wants to know about AI. Okay. Yes, we have included some, but we've put it in the design of the red zones. The red zone in the buffer is very important, getting it reasonably right. And so we've applied a lot of AI in that particular area. But it is coming. The CEO of Demand Driven Technologies, his vision, he talks about, an airliner. The pilot is only driving the thing for a small percentage of the time, probably from takeoff and landing, and maybe diverting around a storm or something. The rest of the time, the computer's driving the aircraft. Why don't we get our systems to drive our supply chains and have our people looking at the anomalies and sorting out the problems that come along rather than sitting there wondering what to buy and what to make and when to do it. Let the system do that. And that's what DDMRP is doing. The system is working for you. In fact, in a lot of cases, the clients find that it works so well they don't even go into the orders every day and approve them. They get automatic approval because they know the system works. And then they spend their time trying to sort out those items that are not working nicely and find out why they're not working nicely. Maybe the data we're using, the lead times or the minimum order quantities are not correct. Maybe the bills and materials are not right. So we find a lot of problems with people's data that cause problems. And we can spend our time fixing those things rather than flying the aircraft. Let the computers do that.
Okay. So
Mm.
it seems like you throw out minimum stock levels completely. Does the system decide on what's in the buffer zone completely?
Yeah, pretty well, because we give it data and it sets up the buffer. And then on a daily basis, it's looking at the data that's pulling out of your ERP system and adjusting the buffer accordingly, automatically. So you don't even have to do anything there. Whereas in the old days, people set their safety stock levels and reorder points and then forgot about it. They probably put them in there 3 years ago and they were wrong then, and nobody's ever gone in and changed them. And then they wonder why they're running out of stock or they've got too much stock. So basically, we're adapting the system on a daily basis based on what's happening out there in your marketplace, what the actual demand is on your business.
Yeah, makes sense. And are most of the big companies in South Africa using a system, either yours or something similar, like this?
Well, there are a number of systems out there. Demand-driven technologies was the first software that was developed in line with the Demand-driven Institute because they had a methodology, but there's no software. So they got hold of demand-driven technologies, or they developed demand-driven technologies to come up with the software. If you go into the DDI website, you'll find there a lot of software which is deemed to be compliant to the methodology. There's loads of it out there now. Um, so, sorry, what was the rest of the question again?
Yeah, a lot of big companies in South Africa
Oh,
using
big companies,
something like
yes.
this.
I,
Yeah.
I think globally there are many, many global companies that are taking on this now. Not so many in South Africa. Take-a-lot's using it. One of my biggest client is Coca-Cola, and we've got 10 countries. Not, we've got countries. 10 countries are using our system to determine what raw materials and packaging materials they need and what levels of finished goods they need in their warehouses, etc. And it's all in one system. So the big boss can look at the big picture across 10 countries in Africa, and he can drill down to a country. He could drill down to a manufacturing plant, drill down to a planner, drill down to an SKU and see what's happening. And it's all in one system, and it's all in the cloud. So typically with that company, we have a meeting every Wednesday afternoon. Anybody who's got problems around the continent of Africa can come onto the meeting. They can say, like, we don't understand this, or this doesn't seem to be working right. Because it's cloud-based, we can see exactly what they can see, and we can fix any problems or any misunderstandings that they might have. I mean, it's really quite fantastic. I was involved in an implementation in India. I never even went there. Company made mattresses, and we did the whole of the education, the training, the systems implementation, all online. So
Fantastic.
COVID's taught us that we don't need to get out of our chairs anymore. We can stay at home and do these
Yes.
things. Yeah. So yeah.
Okay, lovely. Okay, well, since we're over 4 o'clock, we will close
Okay.
up the questions. Thank you. It remains for me to thank Ken very much for telling us about this very interesting topic. I'm sure it's going to help lots of people. Have to be a big company. Um, and yeah, thanks very much, Ken, for your time. And we hope to have you again
It's a
on
pleasure.
another time. Then
Yeah.
on the OCCA front, I just want to thank everyone, all the OCCA members for attending. Thank you for those of you who've signed up as members. I saw someone did already. Thank you very much. And
Okay. Good.
yes, this is our last webinar for the year. We're going to start up again probably in February. So watch your inboxes for another interesting topic. And it remains for me to say, I do wish you all a very good, happy holidays. amazing rest. Don't look at the cell phone for at least 1 or 2 days, hopefully. Put your feet up, get your battery recharged so that you can start 26 full of energy. So thanks to everyone for attending, and goodbye from OCCA.
Thank you. Bye.